Hello viewers. Recently, the Andhra Pradesh Forensic Science Laboratory has conducted a written test for the scientific assistant post for the chemistry graduates. So in this video, I am explaining the solutions for the physical chemistry part given in that question paper. Okay, let us go to the question number 56. 3.6 grams of non-volatile solute is dissolved in 257 grams of benzene, lowered the freezing point of benzene by 0.48 K. If molar depression constant of benzene is 5.14 kg per mole, the molar mass of the solute in grams per mole is. Okay. Now this is the problem related to the depression in the freezing point. So once you know that it is a question related to depression in freezing point, immediately you should get the idea that delta TF is equal to KF into molality. So, so in the given question, they have asked to find out the molar mass of the solute. So you need to find out the molecular weight of the solute that is given. Okay. So how to find out the molecular weight of the solute? See, let us write down one by one. See, 3.6 grams of a non-volatile solute. So weight of the solute is equal to small w is equal to 3.6 grams. Is dissolved in 257 grams of benzene. So this is the weight of the solvent. So weight of the solvent capital W is equal to 257 grams. You convert into kg because in the molality calculations, we need the weight of the solvent in kg. So that is equal to 0.257 kg. And then see here, if molar depression constant of benzene is, see here, he has given Kf. The value of Kf is given, molar depression constant of benzene. Kf is given, Kf is equal to 5.14 K Kelvin kg per mole. And he has already given that once the non-volatile solute is added, lower the freezing point of benzene. That means this is nothing but the depression of freezing point. So delta TF is also given 0.48 Kelvin. So see, weight of solute is given, weight of solvent is given, depression in freezing point is given, and then the Kf value is also given. The only thing is you have to find out the molar mass of the solute. That's it. So therefore delta TF is equal to Kf into molality, and you know that the formula for molality is weight of solute by molecular weight of solute into weight of solvent in kg. So you need to find out this molecular weight of solute. You bring it here and then bring the delta TF here. So that becomes Kf by delta TF into weight of solute small w by weight of solvent in kg. That's it. Okay. Then, so M is equal to, now see here. Now M is equal to, what is the value of Kf? Kf is 5.14. And what is the value of delta TF? 0.48. What is the weight of solute? 3.6. What is the weight of solvent? 0.257 kg. Substitute all these values here. So once you substitute all these values here, see, whenever the decimals are given, just convert them into 10 to the power of exponential factors. That means you just convert it 10 power minus 2. This is 10 power minus 2. Cancel 10 power minus 2. And here it is 10 power minus 1. This is 10 power minus 3. So this becomes 10 square. And the remaining, see, I heard that no calculator is given to you. So therefore you have to do it in a very short time. That is, you have to do the sum in less than 1 minute. So almost the calculations are very simple for this particular problem. So this is 514 by 48 into 36 by 257. 257, 514 cancels 2. And then see here, this is 12 4s are 48 and 12 3s are 36. And then see, this is 2 2s are 4. This is 3 by 2. 3 by 2 is nothing but 1.5. 1.5 into 10 square, that is 150. So the molecular weight of solute M is equal to 150 grams per mole. Over. So your answer is 1. So this problem you can do, if you have little bit practice, you can do within 1 minute, without the use of any calculator. Okay. Then let us move to the question number 57. So the Kf and Kb values of benzene are, so he has in the first line, so they have given Kf value and then the Kb value of benzene. Please write down here. Kf is given 2.57 K kg mole inverse and then Kb 5.14 K kg mole inverse. Okay. The boiling point of benzene is 80 degrees centigrade. See here, this is the boiling point of pure benzene, that is a pure solvent. So boiling point of pure benzene is equal to 80 degrees centigrade. And its freezing point is 5.4 degrees centigrade. So freezing point is also given. Freezing point of pure benzene TF naught is equal to 5.4 degrees centigrade. If the solution of non-volatile solute is added, it freezes at 5.2 degrees centigrade. That means when a non-volatile solute is added, naturally you know that there is a depression in the freezing point. So therefore here, so if a solution of non-volatile solute is added, it freezes at 5.2 degrees centigrade. That means what he has given is that, see, the freezing point of solution that is formed by adding a non-volatile solute is also added to you. That is 5.2 degrees centigrade. So this 5 is nothing but the freezing point of solution when a non-volatile solute is added. And then this is the freezing point of the pure solvent. And we know that there is a depression in the freezing point always. When a non-volatile solute is added, then the non-volatile solute is added, you know that the vapor pressure of the solution decreases compared to vapor pressure of pure solvent. Okay, and then once the vapor pressure of solution decreases, the freezing point also decreases. So there is a depression in the freezing point. Now you calculate the delta TF value. Delta TF is equal to TF naught minus TF. What is the value of TF naught that is given for pure solvent? It is 5.4 and 5.2. So you can write down 0.2 degrees centigrade or you can write down 0.2 Kelvin, because the difference will be the same whether you convert into the Kelvin or you just keep it as it is in degrees centigrade. The difference will always be the same. Okay. Now what you need to find out is that the boiling point of the solution in degrees centigrade. So you need to find out the boiling point of the solution. That's it. Okay. And see here, there is a depression in the freezing point. There is an elevation in the boiling point. So what is that you have to calculate? You have to calculate the boiling point of the solution, because it has given the boiling point of pure benzene. Okay then. See here. Now let's substitute everything in this. So we know that delta TB is equal to KB into M, and we know that delta TF is equal to KF into M. You divide one over the other. Delta TB by delta TF is equal to KB by KF. Molality gets cancelled. KB by KF. Okay. So you know that now you have to calculate the delta TB first, because you know delta TF. See, you know delta TF, you know KB, you know KF. So what you need to do is that you calculate the elevation of boiling point. That is delta TB. So delta TB is equal to delta TF into KB by KF. So delta TF, you know, 0.2, and then KB by KF, you also know about this. So this also very easy to cancel. So the numericals are given, very simple numericals are given for cancellations. So this is 2. So therefore this is 0.4 K. So your delta TB is 0.4 K or 0.4 degrees centigrade, because I already told you the difference will be the same. Okay, so this is 0.4 degrees centigrade. Now, what is delta TB? Delta TB is nothing but, you know that there is an elevation of boiling point. That means the boiling point of solution is greater than that of the boiling point of the pure solvent. So therefore, delta TB is nothing but boiling point of solution T minus boiling point of pure solvent is equal to 0.4 K. That is delta TB. Okay, so you need to calculate this now, because boiling point of pure solvent is already given to you here. See here, it is already given 80 degrees centigrade. Okay, so therefore this is 80. So boiling point of solution is equal to delta TB. This is delta TB 0.4 plus boiling point of pure solvent, that is pure benzene. So 0.4 plus 80 gives us to 80.4 degrees centigrade. So your answer is 2. So it is also very simple. Next, 58. Coming to the 58th question. The vapor pressure of CCl4 liquid at 303 Kelvin is 143 millimeters of mercury. See here, the vapor pressure of CCl4 liquid, in the sense he has given the vapor pressure of the pure CCl4, that is P0 is given to you. The vapor pressure of a solution formed by dissolving 0.5 grams of a non-volatile solute of molar mass 65 gram per mole in 100 ml of the liquid CCl4 in mm is. See, what you need to do is that you have to calculate the vapor pressure of the solution, that is PS. You have to calculate the PS. Okay. So vapor pressure of pure solvent is given to you 143 millimeters, pure solvent, that is CCl4. And you need to calculate the vapor pressure of the solution that is formed by adding a non-volatile solute to the solvent, the pure solvent. Okay. So how many grams of non-volatile solute is added? 0.5 grams. That is weight of non-volatile solute is equal to 0.5 grams. What is the molar mass of the non-volatile solute? 65 grams per mole. You just calculate the number of moles of solute here. So 0.5 by 65. That turns out to be 1 by 130 mole. So you have already calculated number of moles of solute. Then see here. Now here he has given the density of the liquid. See here. See, volume is given and density is given. So this is the density of the liquid and this is the volume. So you multiply this density into volume, you will get the weight of the solvent. So weight of the solvent is equal to density into volume. So that turns out to be 1.54 grams per ml. This is density into volume is 100 ml. So that turns out to be 154 grams. Over. So weight of solvent is, now you know the weight of the solvent. Molar mass of the solvent is already given to you, 154 grams per mole. Now you calculate the number of moles of CCl4. That is weight, number of moles of solvent. So 154 by 154 turns out to be 1 mole. Now this is the problem with regard to relative lowering of vapor pressure. That is Raoult's law. According to Raoult's law, the relative lowering of vapor pressure is equal to the mole fraction of the solute. So therefore, this is relative lowering of vapor pressure is equal to mole fraction of solute. So you know that P0 minus Ps by P0 is a relative lowering of vapor pressure. That is equal to mole fraction of solute. What is the mole fraction of solute? Number of moles of solute by total number of moles. That is number of moles of solute plus number of moles of solvent. Now in the case of the dilute solution, generally what we'll do is that we'll neglect the number of moles of solute in this denominator. So number of moles of solute in the denominator is neglected. You neglect this. So then it becomes number of moles of solute by number of moles of solvent. So this is P0 is 143 minus this is vapor pressure of solution by 143 is equal to 1 by 130. So that is equal to 143 minus Ps by 143 by 130. 143 by 130 is nothing but your 1.1. It is just 1.1. So you can do it very easily. So this minus 143. So 143 minus 1.1 over. So it is 141.9. So always remember, see, and you can also see with even without calculation also you can tick the question very easily. How to tick it? How to choose the option? See here, the vapor pressure of the pure solvent is 143. You know that the vapor pressure solution will always be less than the vapor pressure of pure solvent. So therefore, you just pick up the option which is very near to 143, very near to 143. So what is option very near to 143 is 141.9. Okay. Similarly, you can also do the sum in this way also. It's a simple common sense. You can also do in that way. So this is answer is 3. Over. So therefore, here see the examiner has focused on the elevation of boiling point, the depression of freezing point, and also on the relative lowering of vapor pressure. See the next question. And for this calculations, there is no need for you to use any calculator. See the next question. A solution, that is 55. A solution containing 4 grams of sulfur in 100 grams of carbon disulfide. See here, so he has given a weight of solute. So weight of solute W is given. This is weight of solvent. Weight of solute how much? 4 grams. Weight of solvent carbon disulfide is equal to 100 grams. Again convert into kg, it is 0.1 kg. Boils at, see here, this is the boiling point of the solution. Okay, so the boiling point of the solution is equal to 319.67 K. How the solution is obtained? It is obtained by adding a non-volatile solute to the pure solvent. Then the boiling point of pure carbon disulfide is also given. This is T0 is given. So we know that there is an elevation of boiling point is already there. So therefore this is delta T. What is the delta T? Delta T is equal to boiling point of solution minus boiling point of pure solvent. So that turns out to be 319 is there, 319 is there. So the only thing is you have to subtract these two numbers. 67 minus 30 is 37. See, this is 0.37 K is the elevation of boiling point. So what you need to do, see here, if the molecular formula of sulfur in CS2 is S8, so it is S8. So therefore, if you know that it is S8, you just calculate the molar mass, 32 into 8. So this is the molar mass. Okay. And then what you need to calculate now, you have to calculate the molar boiling point elevation constant. So you have to calculate the elevation of boiling point, that is Kb you have to calculate. Okay. See, weight of solute is given, weight of solvent is given, molar mass of solute is very clear. So you can calculate the molality and you know the delta Tb. So we know that the formula is delta Tb is equal to Kb into M. So you know delta Tb, you will have to calculate the molality using this data. And then you find out Kb easily. Over. See here, delta Tb is equal to Kb into molality. So Kb is equal to delta Tb by molality. So this is the molality we have to calculate. Molecular weight is 4 grams, 32 into 8, and this is 0.1. So just simple calculation. So you'll get 1.64 mole per kg. And here it is 0.37 K. So because the Elevation of boiling point is 0.37 by 1 by 6.4. Now that turns out to be 0.37 into 6.4. You can multiply very easily even without a calculator. So 2.368 Kelvin kg per mole. So answer 2. So this is also a very simple question. Okay. See, this I have explained you very clearly, but once you have a sufficient practice, you will calculate molality directly, and then you'll directly substitute these values in this particular formula. So that you'll get it by practice. Direct substitution, you'll get it by practice. And another question that is also given to you, a solution containing 20 grams of a substance X per dm cube. Remember that dm cube and liter both are same. So solution containing 20 grams of a substance X per dm cube was found to be isotonic with a 4% solution of glucose. The molar mass of X in grams per mole is. See here, this is a very simple one. And isotonic solutions means solutions having the same osmotic pressure. If two solutions have the same osmotic pressure, then it is called isotonic. So, and you know that the formula of osmotic pressure is P1 is equal to P is equal to CRT. You know the formula for osmotic pressure. The formula of osmotic pressure P is equal to CRT. For two different solutions, P1 is equal to C1 RT. P2 is equal to C2 RT. This is for another solution. But isotonic solutions means solutions having the same osmotic pressure. Osmotic pressure will be the same. The temperature is also same. Temperature is same. Gas constant is same. Then what happens? C1 is equal to 100 ml of the solution contains 4 grams and 1000 ml of solution contains 40 grams. So this is the molecular weight of the glucose. We know that molecular weight of glucose is 180 grams per mole. So therefore substitute is here 20 grams by m1 is equal to 40 grams by 180. So therefore that molecular weight turns out to be 90 grams per mole. So this you can do within 1 minute without any problem. You can do within 1 minute. So this is a very simple question. So your answer is 4. Over. So in the next video, I'll explain some more problems to you. Thank you.